Going to talk about slope of a line. Slope of a non-vertical line is the ratio of the vertical change to the horizontal change. That is the change in y over the change in x between 2 points. Slope can be calculated by finding the ratio of the difference in the y-coordinates over the difference in the x-coordinates. So you're taking the change in y, the change in the y values, putting that over the change in the x values. So once again, that's vertical change over horizontal change. Change in y over change in x. Now there is a formula that goes with slope, but don't get hung up on the formula. Think about slope as it is, not so much related to the formula. All you're doing is you're finding the vertical change. That's the change in y over the horizontal change. That's the change in x. So the formula that goes with it is y2 minus y1 over x2 minus x1, but don't get stuck on that. You could easily take y1 minus y2 over x1 minus x2. So to find the slope of the line that goes through those 2 points, you're simply taking the change in y over the change in x. Change in y is the vertical change. Change in x is the horizontal change. So just subtract the y coordinates and put that over the subtraction of the x coordinates. Again, do not get hung up on the formula. Don't try to memorize the formula, because mistakes people will make with that is they'll put x2 minus x1 over y2 minus y1, or they'll take y2 minus x2 over y1 minus x1. They'll get that all confused. It's the change in y, that's the vertical change, over the change in x, that's the horizontal change. Remember what slope is. Don't worry about remembering what the formula is. Change in y over change in x is all you have to remember. Vertical change over horizontal change, also known as rise over run. What is the slope of the line that passes through the given points negative 3, 7, and negative 2, 4? So here you have the points negative 3, 7, you go to the left 3 and up 7, and negative 2, 4, go to the left 2 and up 4. We're going to find the slope of the line that goes through those 2 points. So all we have to do is find the change in y over the change in x. Now it doesn't matter which point is the x1, y1, which point is the x2, y2. Yes, the formula is y2 minus y1 over x2 minus x1, but again, don't get hung up on the formula. You're subtracting the y's over subtracting the x's. So you could take 4 minus 7 over negative 2 minus a negative 3. Or, there is another way, you could take 7 minus 4 over negative 3 minus a negative 2. Either one of those will get you the same thing. So if you do take 4 minus 7 over negative 2 minus a negative 3, on top that's going to be negative 3. On the bottom, negative 2 minus a negative 3, that minus negative turns into plus, so that's negative 2 plus 3. On the bottom, negative 2 plus 3 is 1, so it'd be negative 3 over 1, and that turns out to be negative 3. So the slope of that line is negative 3. But thinking that is rise over run, that's negative 3 over 1, where the rise is negative 3 and the run is 1. So that means this line goes down 3 for every 1 that it goes over. Or you could think of that as the rise being positive 3 and the run being negative 1. So you could go up 3 and to the left 1. So there's a couple ways to think about it. All depends on where you think that negative sign is. It really doesn't matter. It could be on the top or the bottom, either negative 3 over 1 or 3 over negative 1. So the rise could be negative 3. That means you go down 3 for every 1 you go to the right. Or the rise could be positive 3. That means you go up 3 for every 1 you go to the left. Either way you think about it, slope is negative 3. So for every 3 that line goes down, it goes to the right 1. Vertical change is negative 3. The horizontal change is positive 1. Once again, it doesn't matter which point is the x1, y1, which point is the x2, y2. This formula really doesn't matter. You're taking the change in the y coordinates over the change in the x coordinates. What is the slope of the line that passes through the points 3, 1 and negative 4, 1? Again, to find the slope of the line, we're finding the vertical change, that's the change in the y coordinates, over the horizontal change, it's the change in the x coordinates. So to find the vertical change, we're going to take 1 minus 1, and the horizontal change would be negative 4 minus 3. Or you could go 3 minus a negative 4. So the vertical change, the change in the y coordinates is 1 minus 1. And the horizontal change, the change in the x coordinates is negative 4 minus 3. This is the rise. The vertical change is the rise. The horizontal change is the run. Also to note, small letter m is the symbol for slope. So on top in the numerator, taking 1 minus 1, that's going to be 0. So the vertical change is 0. And in the denominator, the negative 4 minus 3, that would be negative 7. So the vertical change is 0. It's not going up or down any. And the horizontal change is negative 7. So think about that. This line is not going up or down any. It's consistently going left and right. So what kind of line is that? It's a horizontal line. Slope is 0. The slope of a horizontal line will be 0. So these 2 points, 3, 1, you go to the right 3 and up 1. Negative 4, 1, go to the left 4 and up 1. You can see that is a horizontal line. One big thing to note here, horizontal lines do have a slope of 0. And you could have known that from the very beginning. Horizontal lines are going to have the same y-coordinate on those 2 points. So if you see 2 points that have, if you're finding the slope of the line that goes through 2 points that has the same y-coordinate, it's going to be a horizontal line. So if the y-coordinates are the same and the x-coordinates are different, it will be a horizontal line. And the slope of a horizontal line is always 0. Why is the slope always 0? Because the rise will be 0. There is no rise to a horizontal line. It's all run, left and right. Slope on this particular horizontal line and all horizontal lines is 0. What is the slope of the line passing through these 2 points? 7, negative 3 and 7, 1. To find slope, we're finding the change in y, that's the vertical change, over the change in x, that's the horizontal change. Again, with the x1, y1, x2, y2, don't get hung up on that and the formula. Remember, you're finding change in y. In this case, it'd be 1 minus a negative 3, or you could think of that as negative 3 minus 1, over the change in x. 7 minus 7, or going the other way, still the same, 7 minus 7. So change in y over change in x. Change in y is the vertical change, 1 minus a negative 3. The change in x, that's the horizontal change, 7 minus 7. So to work through this, 1 minus a negative 3 in the numerator, that would be 1 plus 3 because minus a negative becomes plus. And in the denominator, 7 minus 7 is 0. 1 plus 3 in the numerator is 4. And you still have 0 in the denominator. Now, you may not know what 4 divided by 0 is, because nobody really knows. It's undefined. You cannot divide 4 by 0. If you type that in on your calculator, it's going to give you an error message. It's undefined. So these 2 points, 7, negative 3, you go to the left 7 and down 3, and 7, 1, go to the right 7 and up 1. Those 2 points through those 2 points is a vertical line. And a vertical line will have a slope that is undefined. So all vertical lines will have a slope that is undefined. Why? Because the denominator will be 0. Because there is no horizontal change. Remember, the denominator is the horizontal change or the change in x. There is no change in x. It's not going left or right any. It's all up and down. It's all vertical change. The rise really could be anything. But if the run, the left and right change, is 0, that's a vertical line. And if you have a numerator that's a number other than 0, a denominator that is 0, that is going to be undefined because you cannot divide, in this case, 4 by 0. So all vertical lines have a slope that is undefined. All horizontal lines, as you saw on the last one, have a slope that is 0. So vertical lines have a slope that is undefined. Horizontal lines have a slope that is 0. And with this, from the beginning, you could have known that. You wouldn't even have to go through all this. If you see that the x-coordinates are the same, on those 2 points, that has to be a vertical line going through those 2 points. And a vertical line will have a slope that's undefined. So you wouldn't have to show any of this work. As soon as you see 2 points that have the same x-coordinates and different y-coordinates, that's going to be a vertical line that goes through those 2 points. And a vertical line, all vertical lines have slopes that are undefined. When you think about lines and their slope, there are 4 different types. Positive slope. That's where the line goes up and to the right. So if you have a line with a positive slope, it will go up and to the right because the rise is positive and the run is positive. If the rise is positive, you go up. If the run is positive, you go to the right. That creates a positive slope, which creates a line that goes up into the right. A negative slope is the other way. It's going to go down into the right, because in that situation, either the rise is negative or the run is negative. For example, if you have negative 3 over 4, the rise would be negative 3. That means you would go down 3, and the run is 4. You go to the right 4. So that would create a line that goes down to the right. Or another way to think about that is if you had 3 over negative 5. If you have 3 over negative 5, the rise is 3. That means you go up 3, and the run is negative 5. You go to the left 5. So a negative slope, either the rise is negative or the run is negative, one or the other, not both. If they were both negative, that'd be back here at a positive slope. But if one or the other, the rise or the run, change in y or the change in x is negative, that creates a negative slope where the line goes down to the right. There's two ways to think about that. Either you go down into the right, so the rise would be negative, you go down, the run's positive, you go up, or go to the right. Or you can think about that as the rise being positive, you go up, the run being negative, you go to the left. Either way, it's a negative slope. The line will slant down into the right. The third type is a horizontal line. Horizontal line has a slope that is 0. An example of that would be 0 over 3. The rise is 0. There is no rise. It's all run. It's all left and right. So if there is no rise to a line and it's all run, that creates a horizontal line. How do you know that? By looking at the fraction. The top is 0. The numerator is 0 because 0 divided by 3, in this case, would be 0. Or if you have 0 divided by 5, that's 0. Fourth type is a vertical line. A vertical line has a slope that is undefined. So vertical line straight up and down, because the rise can really be anything, but the run is 0. There is no run. There is no left and right. It's all rise, all up and down. And by looking at the fraction, you can see that the rise, in this case, is 3. The run is 0. It really doesn't matter what the rise is. As long as that's a number other than 0, that's a vertical line. If the run is 0, if there is no horizontal change. So if there is no horizontal change and it's all vertical change, in other words, if there is a change in y and no change in x, that's going to create a vertical line. All vertical lines have a slope that is undefined. All horizontal lines have a slope that is 0. Why? Because on a vertical line, the denominator, the slope in the slope, the denominator is 0. In a horizontal line, the slope in the numerator is 0. So if the denominator is 0, that's going to be undefined. If the numerator is 0, that's going to be 0. So vertical lines have a slope that is undefined. Horizontal lines have a slope that is 0. A negative slope goes down to the right. That's either the rise being negative or the run being negative. And a positive slope will go up into the right. That's where everything is positive. Or you would have two negatives there, which would still make a positive. So positive line goes up into the right. A positive slope goes up into the right. Negative slope is down to the right. Vertical lines have a slope that is undefined. Horizontal lines have a slope that is 0. A function whose graph is a line is called a linear function. A linear function can be represented by a linear equation, such as y equals 2x plus 5. A solution to a linear equation is any ordered pair xy that makes the equation true. Any point that lies on the line is a solution to a linear equation. So if you have a line and a point that lies on that line, take those xy coordinates, substitute them into that linear equation, and it will make a true statement. Both sides will equal each other. So if you take those xy coordinates of a point that lies on the line, substitute them into the linear equation, it's going to make a true statement. Both sides will equal each other. An intercept of a line is a point where a line crosses an axis. So think about in football, when you intercept a pass, you're going to cross over the line between the quarterback and the receiver, most likely, in most occasions. Between the quarterback and the receiver, you have to cross that line in order to make that interception. The y-intercept is the point at which the line crosses the y-axis. So where a line hits the y-axis, that's called the y-intercept. Likewise, an x-intercept is the point at which the line crosses the x-axis. So where that line hits that x-axis, that is called the x-intercept. So the y-intercept is where it hits the y-axis. The x-intercept is where it hits the x-axis. So if you look at this graph, you can see it hits the y-axis at 6. So you could say that the y-intercept of that line is 6. Some teachers or books may say the coordinates of that would be 0, 6, because the x-coordinate is 0, the y-coordinate is 6. But that hits the y-axis at 6, the y-intercept is 6. You can see it hits the x-axis at -5. So this line is crossing the x-axis at -5. The x-coordinate is -5, the y-coordinate is 0. Either way, the x-intercept is -5, the y-intercept is 6. One form of a linear equation is slope-intercept form. Slope-intercept form is y equals mx plus b. When you have a linear equation in this form, y equals mx plus b, the number in front of the x, in this case the m, is the slope of the line. It's the rate of change. B is the y-intercept. That b will be a constant term. It's where the line crosses the y-axis. It's a constant term because there is no variable attached to it. So y equals mx plus b, when you have a linear equation in that form, m is the slope, that's the coefficient or the number in front of the x, b is the constant term, the number without a variable, that is the y-intercept. So we're going to look at some equations and we're going to tell what the slope and the y-intercept is. Starting with this one, y equals 3x minus 5. So that's already in slope-intercept form. It's in the form of y equals mx plus b. Remember, m, the slope, is the number in front of the x, and b, the constant term, that is the y-intercept. So if you're asked what the slope is, it's the number in front of the x. It's 3. If you're asked what the y-intercept is, that's the constant term, the number without a variable. It's where the graph hits the y-axis. In this case, it's -5. Next one, y equals x plus 1. Now to pick out the slope here, you're going to say, well, there is no number in front of the x. Well, there is. It's just not showing. If there is no number showing in front of the x, it's 1. If there's an x there, there's still 1x there. So you could think of being a 1 in front of that. That's the slope of the line. And then the y-intercept, that's the constant term, the number without a variable. In this case, that's also 1. So in this one, the slope is 1 and the y-intercept is 1. If we think back to this, we said the slope is rise over run. Now there's only one number there, it's 3. But rise over run, you could put that 3 over 1. So on that particular line, the rise is 3, it goes up 3, and the run is 1, it goes to the right 1. So every 3 it goes up, it goes to the right 1. Same thing back here, you could think of that slope as 1 over 1, where the rise is 1 and the run is 1. That means for every 1 it goes up, it goes to the right 1. Number 3, y equals 4. There is not even an x there. For y equals 4, you could think of that as y equals 0x plus 4. So you could put an x there. If you put a 0x in, it doesn't make any difference. But you can see the slope now. The slope is 0. Remember, what type of line has a slope that's 0? A horizontal line. So that's a horizontal line, and it's hitting the y-axis at 4. In other words, the y-intercept is 4. This is a horizontal line going through 4 on the y-axis. X equals 8. There's no y there. For x equals 8, that's a vertical line. A vertical line will have a slope that is undefined. And the y-intercept on this, if it's a vertical line going through 8 on the x-axis, there is no y-intercept. So back to this. How do you tell by looking at the equation a horizontal line versus a vertical line versus all of these other ones? Here's the tip. A horizontal line will start off as y equals, and then it'll be just the y-coordinate that it passes through. There will be no x showing. If there is an x showing, it has to be a 0x. So once again, a horizontal line is y equals, and then it's that constant term, that y-intercept that it passes through. That's how you tell that's a horizontal line, just by looking at the equation. Y equals, and then a number on the other side. That's a horizontal line going through that number on the y-axis. For a vertical line, it's going to start off as x equals, and then it'll be the x-coordinate that it passes through on the other side. So there is no y involved. That's a vertical line going through 8 on the x-axis. So once again, a horizontal line will start off y equals, and that'll be the y-coordinate that it passes through. A vertical line will start off as x equals, and that'll be the x-coordinate that it passes through. Very easy to see a horizontal line and a vertical line, but I'll tell you, it's something that's very confusing to people taking Algebra 1 or Algebra 2. Very hard for them to distinguish horizontal lines, vertical lines, and all of these other ones. These other ones I'm talking about will have a slope and a y-intercept. Those will be diagonal lines, either going down to the right or up and to the right. But a horizontal line, again, it's y equals and then the number it passes through. Vertical line will be x equals and then the number of the x coordinate that it passes through. If you have y equals x over 2 minus 5 over 6, now you're going to say that x over 2, what's the deal with that? Well, dividing x by 2 is the same as multiplying it by 1/2. So that'd be the same thing as y equals 1/2 x minus 5/6. And now you can see the slope in the y-intercept. Slope on that's the number in front of the x, it's 1/2. And the y-intercept, that's the constant term, the number without a variable, that is negative 5/6. Going to write the equation of this line. This line has a slope. Remember, small letter m stands for slope. It has a slope of 1/5 and a y-intercept of -3. So this line crosses the y-axis at -3 and has a slope of 1/5. So if we're going to write this line in slope-intercept form, y equals mx plus b, we're just putting 1/5 in for m and -3 in for the y-intercept b. So this would be y equals 1/5 x minus 3. That is the equation of the line that has a slope of 1/5 and a y-intercept of -3. If you have a slope of -6 and a y-intercept of 5, once again, to write that in slope-intercept form, y equals mx plus b, just substitute -6 in for m, that's the slope, and 5 in for b, that is the y-intercept. So the equation of the line that has a slope of -6 and a y-intercept of 5 is y equals -6x plus 5. For this line, you have to pick out the slope in the y-intercept. I'd start with the y-intercept. Look to see where it hits the y-axis. This hits the y-axis at 4. And then pick out the slope. How many does this line go down and over? So if you see that it crosses 4 there, you can go down to the origin, and then over you can see it crosses the x-axis at 3. So the line goes down 4 into the right 3. Any point on this line goes down 4 into the right 3. You go anywhere on this line, if you go down 4 to the right 3, you're still going to end up on the line. So the slope is -4/3, and the y-intercept is 4. So with the slope being -4/3 and the y-intercept being 4, substitute those in the slope-intercept form. Put -4/3 in for m, 4 in for the y-intercept, and be y equals -4/3 x plus 4. That is the equation of that line. Any linear equation can be written in slope-intercept form, just by solving for y. We're going to write the equation in slope-intercept form and then also pick out the slope and the y-intercept. So to get this in slope-intercept form, we want to solve this equation for y. So we need to move the 5x to the right side and then move -4 to the right side. So to move that 5x to the right, we're going to subtract 5x from each side. You end up with -4y equals -5x plus 16. Now you have to get the -4 away from the y, so divide each side by -4. Now when you divide each side by -4, you're dividing each term by -4. So if you divide -4y by -4, that'll just be y. And if you divide -5x by -4, dividing two negatives, that makes a positive. It's going to be positive 5/4 x. And then 16 divided by -4 is -4. So now you can see the slope in the y-intercept. Remember, the slope is the number in front of the x. In this case, it's 5/4. And the y-intercept, that's the constant term, the number without a variable. In this case, that's -4. So the y-intercept, you could say that's -4, or you could put the coordinates down of 0, -4. Either way, it's the same. Slope is 5/4, the y-intercept's -4. The equation of the line is y equals 5/4 x minus 4. For this line, -3/4 x plus 1/2 y equals -1. Notice you have some fractions to deal with. You could add 3/4 x to each side, but if you wanted to get rid of the fractions, you could also multiply the entire equation by either 4 or -4. That would clear out all the fractions, at least at the beginning. So if you add 3/4 x to each side, you're going to have 1/2 y equals 3/4 x minus 1. Then you have to get the 1/2 away from the y. To get that 1/2 away from the y, you have to divide by 1/2, which is the same as multiplying by 2. When you divide by a fraction, you multiply by the reciprocal. So think of multiplying each side by 2. When you multiply each side by 2, you're multiplying each term by 2. So if you take 2 times 1/2 y, that'll just be y. If you take 2 times 3/4, yes, use your calculator. That's 3/2 x. Actually, try to not use your calculator. That's 3/2 x, and then 2 times -1 would be -2. So y equals 3/2 x minus 2. That is that equation in slope-intercept form. So we got that equation in slope-intercept form by solving for y. Now you can pick out the slope in the y-intercept. The slope is the number in front of the x. It's simply 3/2. And the y-intercept, that's the constant term. Reason it's called the constant term is because it doesn't have a variable attached to it. It stays constant no matter what. That's -2. That's where the line hits the y-axis, at -2. The coordinates of that, you could say, are 0, -2. Slope is 3/2. This line would go up 3 for every 2 that it goes to the right. And the equation of this line in slope-intercept form is y equals 3/2 x minus 2. One of the easiest ways you can graph a linear equation is by using slope-intercept form. First thing you need to do is get the equation in slope-intercept form, y equals mx plus b, and then pick out the y-intercept. Once you see the y-intercept, put that on the graph. So put that point, that y-intercept on the graph, and then use that to get another point. By that I mean, from the y-intercept, use the slope, rise over run, to move and get another point. And then once you have those 2 points down, so once you have the y-intercept, you use the slope to get another point down, then draw a line through those 2 points. It only takes 2 points to make a straight line. So write the equation in slope-intercept form, put the y-intercept down first, use the slope to move and put another point down, and then draw a line through those 2 points. And that's what we're going to do here. We're going to graph -2x plus y equals 1. First step is to get it in slope-intercept form, y equals mx plus b. So to solve this equation for y, you need to move that 2x to the other side by adding 2x to both sides. You have y equals 2x plus 1. Now it's in slope-intercept form. It's y equals mx plus b. So you can pick out the slope in the y-intercept. The slope is the number in front of the x, that's the 2. And the y-intercept, that's the constant term, the number without a variable, that's 1. So to graph this, we're going to start with the y-intercept. You always start with the y-intercept. Put that down first. We're going to put a point at 1 on the y-axis. And then from there, the slope is 2. That's also known as 2 over 1. So as rise over run, that would be 2 over 1. So from that point, we're going to go up 2 and to the right 1 and put another point down. So we put the y-intercept down first. We use the slope, which it says there is 2, but that's the same as 2 over 1. The rise was 2, we went up 2. The run was 1, we went to the right 1, put another point down, and drew a line through those 2 points. That is the graph of this -2x plus y equals 1, and it's also the graph of y equals 2x plus 1, because those 2 equations are the same. What is the graph of 4x minus 7y equals 14? I'm going to get this in slope-intercept form. Use the y-intercept and the slope to graph this equation. So to get this in slope-intercept form, you need to move the 4x to the right side by subtracting 4x from each side. If you do that, you get -7y equals -4x plus 14. Now to solve for y, you need to get that -7 away from the y. To do that, you have to divide each side by -7. When you divide each side by -7, you're dividing each term by -7. That turns out to be y equals +4/7. Watch your signs. -4 divided by -7, that's a +4/7. And then 14 divided by -7 is -2. So the slope on that line you can see is 4/7. That's the number in front of the x. And the y-intercept, that's the constant term, the number without a variable, that's -2. So to graph this, always start with the y-intercept. Put that down first. So put a point at -2 on the y-axis. And then from that point, you're going to use the slope to get another point. It's rise over run. So this line rises 4 for every 7 that it runs to the right. So from that y-intercept, you're going to go up 4 and then to the right 7 and put another point down. So go up 4, to the right 7, put another point down. You have 2 points. That's all it takes to make a line. Draw a straight line through those 2 points, and that is the graph of that equation. 4x minus 7y equals 14. That's also the graph of y equals 4/7 x minus 2. Those 2 equations are the same. One's in what's called standard form. The other one is in slope-intercept form. We're going to find the slope and the y-intercept of this line. It doesn't really matter which one you find first. Y-intercept's probably the easiest. Look to see where it crosses the y-axis, and it hits the y-axis right there at -5. If you count down from the origin, it's crossing through the y-axis at -5, so the y-intercept is -5. You could say the coordinates of that would be 0, -5, or just say the y-intercept is -5, it's the same. Now to find the slope. It crosses through the y-intercept, right through one of those square grid corners. crosses through perfectly. So you want to find another point where it crosses through one of those square grid corners perfectly. So it looks like it crosses through perfectly right there, even up here, but a little closer to the y-intercept. Want to get as close as we can. It crosses through right there. So you can see that if you go up 2 into the right 1, it's crossing through one of those square grid corners perfectly. And that's how you find the slope. Start at the y-intercept, or start where it crosses through one of those square grid corners, and then follow the line up. How much are you rising? How much are you running in order to see where it crosses through another square grid corner perfectly? So if you do that on this, you can see it goes up 2 into the right 1 from the corner of one of those square grid marks to the next corner where it crosses through perfectly, up 2 into the right 1. That is the slope of the line. So the slope of the line is 2. The rise is 2. The run is 1 on that particular line. Slope is 2. The y-intercept's -5. For the next line here, that's a horizontal line. What is the slope of a horizontal line? There is no rise. The rise is 0. It's all run. If the rise is 0, it's all run. The slope on that would be 0. And also it's crossing through the y-axis at 4. So the y-intercept is 4 and the slope is 0. All horizontal lines have a slope that is 0. This horizontal line has a slope that's 0 and hits the y-axis at 4. So the slope is 0 and the y-intercept is 4. Looks like somebody made a mistake. Glad it wasn't me. One person found the slope between 2 points. What error was made? So these are the 2 points, 3, 4, and 2, 7. To find the slope, they started taking 4 minus 7 over 2 minus 3. And that is the mistake. Remember, slope is rise over run. So to find the change in y, this person took 4 minus 7, but to find the change in x, they took 2 minus 3. That's the problem. If you're going to start by finding the change in y and taking 4 minus 7 to find the change in x, you have to come back here to this point and do 3 minus 2. Or you could start with, to find the change in y, you could do 7 minus 4, as long as you come back here to find the change in x and do 2 minus 3. So again, the slope formula is, and don't get hung up on the slope formula, the slope formula is y2 minus y1 over x2 minus x1, but we don't want to get caught on memorizing that. Remember, you're finding the change in y over change in x. If you do the change in y as 7 minus 4, the change in x would do 2 minus 3. Or change in y being 4 minus 7, come back here to do the change in x, 3 minus 2. So there's two ways to do this, either 7 minus 4 over 2 minus 3, or 4 minus 7 over 3 minus 2. But that is the mistake. Suppose the equation y equals 12 plus 10x models the amount of money in your pocket, where y is the total in dollars and x is the number of weeks from today. If you graphed this equation, what would the slope represent in this situation? So y equals 12 plus 10x, you can move that around, make it y equals 10x plus 12, doesn't matter. But now it's in slope-intercept form. You can see the slope is 10 and the y-intercept is 12. Again, if you graphed this equation, what does that slope represent? Y is the total in dollars. X is the number of weeks from today. The slope, which is 10, it's the number in front of the x, represents the amount that you put in your pocket each week. Now, this is assuming you don't wash your clothes, apparently. But that 10 represents the amount that you put in your pocket each week. Another question is, what does the 12 represent? If you're putting $10 in your pocket each week, x is the number of weeks, what does that 12 mean? Well, that 12 would be the starting amount that you had in your pocket. So you started with $12. You're putting $10 in your pocket each week. Once again, the slope, in this case 10, represents the amount that you put in each week. For the linear equation 5x minus y equals 2, which of the following has a value of 5? So what is that 5? Well, if you get this in slope-intercept form, you can see what that 5 is pretty clearly. 5x minus y equals 2. To get that in slope-intercept form, we would subtract 5x from each side. So we want to get the y by itself. Subtract 5x from each side. You have negative y equals negative 5x plus 2. Make that a positive y. Divide each side by negative 1. If you divide each side by negative 1, you're dividing each term by negative 1. And if you divide each term by negative 1, you get y equals 5x minus 2. Again, the question is, what is the 5? Well, the 5 is the number in front of the x when it's in slope-intercept form. If that 5 is the number in front of the x in slope-intercept form, that 5 happens to be the slope, and that happens to be letter A. What is true about the line that passes through the points 3, -7, and 3, 2? You should already have the answer by now. Notice the x-coordinates are the same. If you remember back a while ago, when you have 2 points and a line that goes through those 2 points and the x-coordinates are the same, what type of line is it? Think about it. If the x-coordinates are the same on 2 points and the y-coordinates are different, what type of line goes through those 2 points? It's going to be a vertical line. Slope on that, if you want to find the slope, so if you didn't realize that the x-coordinates were the same and you proceeded to find the slope by taking the difference in the y-coordinates, say 2 minus the -7 over the difference in the x-coordinates, 3 minus 3, you're going to end up with a denominator of 0 because a vertical line has a slope that is undefined. You can't divide 9 by 0, it's undefined. So with the slope that's undefined, that means it's a vertical line. All vertical lines have a slope that is undefined. Letter H. What is the slope-intercept form at 3x plus 2y equals 1? So we're going to take that equation and get it in slope-intercept form. To do that, we're going to solve this equation for y. To solve that for y, we've got to move the 3x to the right side. To move that 3x to the right side, subtract 3x from each side. If you subtract 3x from each side, to get 2y equals -3x plus 1. You have to get the 2 away from the y, so divide each side by 2. When you divide each side by 2, you're dividing each term by 2. If you divide each term by 2, you end up with y. 2y divided by 2 is y. -3x divided by 2, you're going to write that as -3/2 x, so you can see the number in front of the x because that's the slope. And then 1 divided by 2 is just 1/2. So that equation in slope-intercept form is y equals -3/2 x plus 1/2. The slope is -3/2 and the y-intercept is 1/2. And the answer is letter B. What is the y-intercept of the graph of 5x minus 9y equals 45? Well, one of the ways to get the y-intercept is to get it in slope-intercept form. To get that equation in slope-intercept form, we're going to solve it for y. Y equals mx plus b, that is slope-intercept form. So to solve that for y, I want to get y by itself by moving the 5x to the other side. To move that 5x, subtract 5x from each side. You end up with -y equals -5x plus 45. Now I need to get the -9 away from the y, so to move that -9 away from the y, divide each side by -9. That means you're dividing each term by -9. So if you divide -9y by -9, that's positive y. -5x divided by -9, that's going to be positive 5/9 x. And 45 divided by -9 is -5. So what is the y-intercept? It's the constant term, the number without a variable. And in this case, it's pretty easy to see. It's -5, letter H. Which of the following is a graph of 4x equals -1/2 y minus 1? A little tough to tell just by looking at them. But if we get that in slope-intercept form, you are able to see the slope and the y-intercept, then you're probably able to pick out the graph. So we're going to take that equation, 4x equals -1/2 y minus 1. We're going to get that in slope-intercept form. We're going to solve that for y. Get it in the form of y equals mx plus b. So we want to get the y by itself. To do that, we're going to move the -1 to the other side by adding 1 to both sides. And when you do that, you get 4x plus y equals -1/2 y. So now we need to move that -1/2 to the other side, get it away from the y. Remember, when you divide by a fraction, you're multiplying by the reciprocal. So really, we're dividing by -1/2, but you could think of that as multiplying both sides by -2. So if you multiply each side by -2, you're multiplying each of those terms by -2. So if you take -1/2 y by -2, that's positive y. And if you take 1 by -2, it's -2. And 4x times -2 would be -8x. So even though that's switched around, it's -8x minus 2 equals y, that's still slope-intercept form. It's y equals mx plus b. M is the slope, that's -8. B is the y-intercept, in this case, that's -2. So you have a slope of -8 and a y-intercept of -2. So you're looking for one of these lines that has a slope of -8. Remember, a negative slope will slant down and to the right. So you're looking for a line that slants down and to the right. You can forget letter B and forget letter D. Those slant up and to the right. It could be A or it could be C. So down and to the right could be A or C. We're looking for a slope of -8 and a y-intercept of -2. So each of these goes down and to the right, but there's only one of them that has a slope of -2. That's this letter C. So letter C there has a slope of -8. It goes down 8 and to the right 1. And it also has a y-intercept of -2. So the correct answer here would be letter C.